can hear me, wave your hands. I'll try to go as slow as possible because the connection is not the best. So yeah, can you hear me? Okay. So basically, today I would like to. So I would first like to apologize. I'm not there in person. I couldn't make it due to family issues, but I hope we can still get the best out of this. So today I'm here to speak to you about Sherlock. Now, first question that comes to mind: who am I? I'm a developer at Booking.com. I'm currently working there on migrating what we have now in Booking.com to a set of services, so a service-oriented architecture. For that, we need to deliver what we are serving our customers from our monolith set of services. Now, a colleague of mine spoke earlier today at the conference as well about how we're doing that. His name is Ivan Kruglov. I would like to carry on more on another level on what implications do we have when building services at a large organization. I recently delivered a reservation search service, basically a component which we would like to provide to the whole world for what people get when they do a booking at Booking.com. So your reservations, how to search through them, how to get stats on them, and so on. Now, this covers a bit what I'm speaking about. So Sherlock is a reservation search engine. Whenever you want to see your reservation on your My Bookings page on Booking.com, or whenever the hotel wants to see who has reservations there, this is the service that is being used. Now, what this means is that every request that comes to Booking.com for such a purpose is processed through our service. You can imagine that Booking.com is a very large, has a lot of traffic, and we also have a lot of bookings. So our current data set is we have over 1 billion bookings right now at Booking.com, and for those we get a lot of requests to retrieve data for what the booking is, whether it's from the guests themselves or from the hotel, or actually from the search results page where we want to display statistics, for example, on hours for the sake of persuasion and so on. Now, our system is getting 20,000 requests per second. That's a sizable amount, and part of our requirements is to serve those requests in less than 50 milliseconds, because otherwise we impact our other business components. Now, this is also the reason why I'm speaking at this conference. I believe it's from the name, it's a high load, and this is a very highly loaded system. It's one of the critical systems at Booking.com. This system fails, and we can serve requests. Now, why am I here? So carrying on from the previous slide, basically, I'm here to speak about what we have built. So I'll dive a bit into the technical implementation of how it was built and how we accomplished it. But at the same time, I would like to address something which is why we decided to go for a homegrown solution instead of a generic solution like any other search engine, like Elasticsearch or like using Lucene backend and so on and so forth. And on the lines of that, I would like to discuss not only how to scale such a service, but also scaling innovation at the company. What actually brings back to your developers, to the teams or to the company? How do they benefit from such a service, and how do the users benefit from that as well? How is it going? So you build a service and it's working and it's fast, great. But you also need to be able to get teams inside the organization, especially in a very large organization like we have, where we have more than 1,000 people working in development. We need to get people to adopt this new service and be ambassadors for it and push more teams to use it instead of using the legacy systems that we have. This is the reason why I would like to speak to you. Now, to get right into it, I've sketched out what I believe are the 5 phases of delivering such a project in an organization. May I ask that someone mutes the mic there, because I hear myself, I hear the echo. So I believe there are 5 steps of delivering such a product in a large organization. And I've sketched them out here. There's a preparation phase where basically you do things like gathering requirements, getting consensus from your peers and from your from the organization itself, because you cannot push a product without getting the business consensus. How you plan to do a migration plan from from the old system to this new system, what this migration plan involves in terms of resources, and what would your MVP look like. This is all in the preparation phase, and this is something you need to be very clear about, especially trying to pitch this to your fellow peers. The next phase is the implementation. This is something where I believe most people in this room are technical people, and we're more familiar with how to implement systems. So you have to ask questions like, what technology that you want to use? What traits do you have? What optimization should you go for, which are not mature? What type do you have in front of you? Have people to work with you? Is there work, or are you working alone? And what sort of also will implement the MVP. The next 3 phases are more the phases which I don't hear a lot of buzz around in talks about such systems, and I would like to really stress on them and put them in to give them their own categories. So there will be bugs. It's never, and I will get to that later in the talk. You also need to do people to use your service. You can't do it alone. Yeah, you have to get consensus, and you have to get the synergy from the whole ecosystem. And finally, profit. You win. Win when you provide something which is useful for the business, it brings revenue. When you provide something which is useful for other devs, when it brings inspiration for them to build similar services, and when it's useful for other services in this initiative to template or backbone for other services to work as well. Now let's dive into the first step. And at this moment, I would like to highlight what preparation here means. For me, when I think about preparation, I think about how much. First thing I need to ask is how much resources I need to ask from the company. So what sort of space requirements do I have? I mean, this is talking about more than 1 billion reservations. How am I going to store those reservations? How am I going to index them? What are access patterns do I have? And during the work on Sherlock, we have noticed that, for example, we have a lot more requests to read the data on a large scale than to fetch single reservations. And this shaped our system entirely. And this sort of also influenced heavily why we decided to go for a homegrown solution, because most search engines out there, they're optimized for the general use case, the generic use case. You want to search for something, but we have actually figured out that our searches are always in a certain context. They're in context of a certain region you're searching for. For example, you book in Amsterdam. It's always constrained by a set of dates. It's also constrained by one user when you look at your bookings. So we are able to heavily or hyper optimize our service to work for our use case and not care about all the extra features which other services give us, making our system more lean, maintainable, and also speedy when possible. Can you hear me? Okay. Now, what we did in preparation as well is we wanted to we need to prepare additional value to our service. So we say our service will do not only what the old system is doing, but also provide more analytics, provide authorization on top. And this is how we get consensus for what we're doing. So we're able to add more value without asking for a lot of resources, and also align with the future vision of the company. We set a migration plan where we said we will do the initial migrations ourselves as service owners, service creators. And this is super critical because whenever you push with a new idea, you will be asked, what value does it bring? What's the return on investment? And some questions are very hard to answer because you don't have data for them now. And you can't expect to start a project with having the data of what ROI you will have at the end when there's nothing similar to it before. So you need to, dig deep yourself. You have to dog food yourself, throw yourself in the hole and get something running. And then the domino effect will happen. People will adopt. Also, when they say, what does an MVP look like? And this is something which I always found quite interesting, because an MVP is not the hackiest solution to get something running. It's actually proving what concept you're pushing forward. I'm pushing forward a reservation search engine, which serves a lot of requests with low latency. Now it's not equivalent to wrapping our Perl and MySQL code base with an API that searches for MySQL, because that will not prove any concept. It will just be a waste of my time, and also no benefit to the business. So an MVP is something which proves the concept. So it's not only about getting something out there quick, it's getting out something which aligns with your vision, which you initially proposed. Now, this is for us, while building Sherlock, we have agreed that an MVP is a minimal search service which does not support more than pages of search results, because as you know, search engines, the more pages you request back from the service, the slower it gets, especially when you have sharded systems, scat together, and the merge operation is very expensive then. So we decided to have a minimal set of data returned back, but on the full data set. Yeah, so the search would run on billion plus reservations and do so in less than 50 milliseconds. If we cannot do so, then our concept has failed. We cannot prove that we can do anything. So these are the points I discussed. And moving into the beefier material, so the implementation, how did we get this happening? Now, when you speak about implementation, there's a lot of decisions which need to come in. So which language did you use? What data structure was there? Storage, indexing, super important is the indexing part. How to get updates for your data, communication between the sharded system and so on, and of course the reliability. So to give you a bit of an overview of what Sherlock is, it's a sharded system. So we have data split of n shards, and we have a central coordinator, and this coordinator is the one which receives the requests and then spans out to all the shards, gathers data from them, merges it back, and then serves back your search request. This was our problem we had to solve. We didn't have any solution for it yet. Now, what value do we bring by building something ourselves and not using something like Elasticsearch? Is the fact that we give control to our developers to push code to our search engine, to apply ad hoc filters, ad hoc sorting functions, and at the same time, when they want to create new experimentation, they want to add new indices to search reservations on, they can do so on their own. They don't need to involve us in this process. And they don't need to care about the scalability of the system when they do so, because adding a new index should not be a scalability hazard. These were all factors which influence all our decisions. So when it came to the language of choice, we chose to go with Java. Which was quite a challenge at .com, because we have a lot of Perl. Pushing forward to use a new language at this scale is not the easiest process, but that's another talk. So we wrote it in Java because we wanted a very efficient system. So we didn't have lots of choices of languages, except that when you think about the speed on its own, to choose a language, it's actually it'll be pretty naive. So we actually wanted to get a language which we had a lot of developers familiar with, people who would pick up this project and push it forward. And this is where working in a large organization comes into play. We cannot be unilateral on these decisions. We cannot say we just choose Java, or we just choose Go, or we just choose whatever language. It has to be something where people are familiar with. Of course, keep in mind that with any choice of language, you have some drawbacks. So we have, for example, Java, you have the garbage collection problem. And this is a problem which is very hard to solve, especially at large scale. You get slowdowns, you get spikes of speed, and you need to deal with this. We also have some C code written, which is connected via JNI. This code is the one which does all the indexing work. And I'll speak about that in the next slides. So what do we choose for data structure? We chose that we will put our reservation, instead of being in multiple tables with the very normalized structure, we'll denormalize it into a single binary blob encoded in protobuf. The reason was that we have a lot of numbers stored in reservations, so a lot of integers, and the var-int encoding really helps compress the size of our data set massively. So it went down by a factor of 2, actually, because of this. If you get we wanted to have a single document with all the data on the reservation, which meant we get a lot of data duplication, but that was also a trade-off willing to take. It was schematized, so people would know beforehand your request or service what data they expect to come back, and if they had a different schema, it's also there's compatibility, backward and forward compatibility with both. It was really at that moment when we started, it had a very fast serialization and deserialization times, and this is something we needed to do because when running a search query which matches millions of reservations, we need to actually fetch all of those from local storage, which lives on disk, deserialize the protobuf, put them in a Java object, operate on them, and so on. Which brings us to the storage, and for that we wanted to build a system, and what we learned heavily was that when building such a service, it's super helpful and super critical to own your entire flow. You have no reliance on external systems or services, which means you can work in complete isolation. So our shards, for example, have multiple replicas. They do not communicate, and which means that every shard has its own view of the world. Even no communication between other shards. It's just the shard believes that these are all the reservations there are in the world. And this makes it very simple to reason about when you talk to one shard. It makes it a bit more complicated when you want to merge the results, but still, you lose the need for consensus because you do not need agreement between the shards in which state they're in. How we manage to get around that and to have consistent data set will be discussed in the slide about updates, how we get updates. So for storage, we use local storage, which is an embedded database called RocksDB, developed by our Facebook. The interesting patches we added to RocksDB, which were internal fork, is we added some C code inside the RocksDB modules to actually serialize and deserialize data on the JNI side. So we don't need to do it on the Java side, so it's very DC friendly then. What we store in RocksDB is actually separated into 3 sets of data. We store the reservations themselves, the indexes, and metadata for them. And for every one of them, we have a different structure of data inside to optimize it for that. We're very read optimized, as I mentioned at the beginning of the talk. And this is why our SS table formats in RocksDB are also very read optimized. We do not, we can accurately predict our write rate, how many bookings we take, and we can extrapolate that for a very long time. What we cannot predict at all is our read rate, because if some developer in some team or some product decides to be launched, which depends on reservations and depends on Sherlock, we had that before, we can double our traffic overnight, and we need to be really provisioned enough, and we had to have the capacity and optimizations for all the read purposes. And this brings us to indexing. What does it mean to have a homegrown solution for indexing, and how did we do it, and how did we enable innovation with it? So we used what's called bitmaps. Drawing bitmaps are very interesting data structures, which are basically a collection of integer arrays, which is a mix between raw bitmaps, raw uncompressed bitmaps, and compressed bitmaps. And unlike traditional bitmaps, when you want to do intersections, or when you want to do to check for existence inside a bitmap, it's not a linear operation. The size of the bitmap, you don't need to check every single entry. You basically you can apply set operations. I mean, as opposed to other implementations of it. And the interesting thing is that it's heavily compressed because of the fact that it uses prefixes for integer characters, and it will reduce the data size you store. Instead of storing 4 bytes for an int, it might actually end up storing 2 bytes only. You can read more about that in the paper. Paper provided for roaring bitmaps. It enabled us to have a lot of innovation scalability, because we started Sherlock having a handful. We had 6 indices and reservations. As of today, we have 60 indices and reservations. So we're able to grow 10 times the number of indices without actually needing to increase the disk size that we use. Also, we have implemented a JNI plugin for roaring bitmaps, so we can actually do everything on the C side. We don't need to do anything on the Java side, making it GZ friendly. And it's standard indexing software. It's used in Elasticsearch, it's used in Lucene, and so on. How we get updates is actually a reason why we have a very resilient system. The reason is, as I said, our shards live in isolation, which means that we need to make sure that our shards are not sync updates, they're not out of date, they're not falling behind. And for that, we use Kafka to deliver updates to every single shard. This means the updates come in real time, so we're sure that we're not falling back behind enough. We have a algorithm in place to detect you're falling behind the offset from Kafka. We have created for updates in a way which updates are idempotent. It means that you can apply the same update many, many times and you don't change what the data set has. It's not an incremental update, it's actually an overwrite of what the data is. This is a very powerful thing to have in your system if you're taking a lot of updates. Makes it much more resilient. We have a concept of a sequence ID, which is, as I mentioned, how you detect how far behind you are on data. And this is where we had algorithmic monitoring on top. And we have redundancy among the many replicas. So we don't need to care about one shard going down, because we have more shards up, which have the same updates coming from the Kafka stream. For communication between the shards, we have an encrypted communication line, which so it's using SSL encryption on the wire, which is something we had to deal with, because it adds a bit of an overhead. It's not as you would expect to be super slow. It's actually not, but we made a conscious decision that even if it were to add a lot of latency on the wire, we were willing to take it to protect data on the wire, because we do not trust even our internal networks. This is how we would like to operate. So the communication is secured by that. We terminate SSL at the Nginx layer, which is deployed on every single shard and the coordinator. We own the client, and this is where we're able to apply and enforce our SLOs and SLIs. So service level objectives and service level indications. So basically, if we're at any point in time going to give you a guarantee on what service you get from us, we cannot open the floodgates for any client to be used. We need to have retries there ourselves, back-off strategies for retries, short circuiting, timeouts, error handling. All this stuff needs to be delivered to the client and that used by developers for ease of use and reliable and resilient interaction with our service. We also added some layers of resilience. As I said, we're introducing this new idea of services at Booking.com, and this is very challenging. At the same time, it's very different from whatever we thought about. I mean, how do you change the mindset of hundreds of developers from thinking of this as a local subroutine or a local function, which you call, to be actually something over the wire? So we had to introduce some things along the way to make developers and people more aware of what this means. So we introduced something like Chaos Monkey. Pending requests, we were sure that we do not bring down the website when actually errors happen, which are bound to happen. We added some automation on recovering dead nodes and recovering the service, deploying new shards, and so on. We like to run our applications on multiple data centers. And whenever you have such an application with multiple DCs, you need to make sure that you don't have any cross-DC traffic as much as possible, so you save latency. And you also introduce a lot of other problems like network partitioning, which happens a lot. And at this point, you you don't need to make yourself understand what that means, but you have to build your system in a way which deals with that properly. And when it comes to, of course, distributed systems, you have the CAP theorem, which so consistency, availability, and condition tolerance. We decided to make our service highly available and eventually consistent, but you can only open both, impacting reliability. And the reason is that we have a very predictable inbound traffic of writes or new reservations that we can rest assured that we will not hit any consistency issues anytime soon. We have our alerting and monitoring set up for that. But we'd rather be able to serve our website and serve bookings and serve a search page and not stop that because we're not consistent. For liability, I mentioned we have some monitoring on the client side, so we always expect to see alerts or monitors from what the client perceives, not what the service perceives, because that's what really matters. If the client perceives a 1 second timeout and your service perceives 20 milliseconds, then something is wrong along the wire, and your client doesn't really care. You have not fulfilled your SLIs or SLOs, and this is something which was discussed in the previous talk of mine, basically discussing how the client and service might completely disagree on what latency means, and that at the end of the day, what really matters is what the client sees. We don't care a lot about non-business critical health alerts. So if the system is doing, sure, if you have a load average of 100, it's something we care about. But if you have a high load average on your machines, but the business metrics are intact, this is not something which would wake me up in the middle of the night. We always set our health alerts on business metrics, what the business is healthy or not. We have alerts on anomalous usage, for example, especially when such sensitive data like reservations, which have a lot of personal information. We would like to know who's using the service in an anonymous way. And we have decided, and it came very handy for us, whenever we build any such service which provides a lot of search, we would like to create the use cases of people who want to come from our front-end website on Booking.com, or people who run cron or batch scripts to fetch statistics. And these workloads should not exist on the similar clusters. So we decided to split up the cluster batch and real-time cluster. And this is something which came in very handy whenever we have buggy scripts or we have people who want to build massive dashboards internally. And they have a time of 30 seconds, but with having them multi-tenant on the same cluster, which serves things less than milliseconds, is a good idea. And then I would like to move to the topic of, we have the system built, we have it set up, and we have all the reliable and resilient features around it. I want to merge these two topics together, bugs and adoption. And the reason why I want to do so is way too many times it's the case that we believe that we cannot release a product and we cannot have adoption unless there are no bugs. This is unrealistic. When we released our service first, we had massive bugs. We had bugs which showed wrong prices even. We had really big bugs. And this is funny to some meaning, the definition of funny, but it's actually true. And the reason is that we're paranoid and we're motivated to release quickly. And the reason is bugs are inevitable. Whether you have tests or not, whether you do your best or not, you will still face bugs. And we'd rather have feedback earlier from the customer before it's too late, before we never release anything and it's just vaporware. And this is where a very common phrase at Booking.com, if you decide to join a company, would be to test in production. Yeah, it's not our common way of doing things. However, testing in production is sometimes not a bad thing. You would some bugs or some issues you only find when you go full out. On the adverse side, this is adoption. How do you also get adoption when people also experience a lot of bugs? And this is where you have to do it yourself. If you migrate the first set of users, the first set of systems yourself to use your new service, and you face the initial set of bugs, you can deal with it. You can suck it up. And then once you have that, and once the service is working and it has users, domino effect happens. Many more services start using your service. You have a higher adoption, and at the same time, you don't face these major bugs with other clients. You have already solved them yourself. The smallest things matter the most in adoption in a large organization. So we had a lot of feedback and a lot of pushback from people to use our client, which we provided, because it had what they mentioned as non-intuitive function names. So we had our client would say client, search, filter, score. So we had a score for each document. They weren't unfamiliar with the word score, so just renaming that score to sort got 5 more teams to use our service because they were able to understand it more. And it's really the small things which you think are just, you've done all this amazing product, this amazing service with all this technology, no one's using it because at the end of the day, it's a people problem. It's not a technology problem. And what really helped us along the way is getting ambassadors on board. Yeah, people who evangelize your product when you're not there. People who are so proud or so happy to have used your service that they just go out and make more people use it. And you only get that if you're there with them, and if you're not trying to let them do all the work. You do the migrations yourself, and you show sympathy, empathy towards the request of the answer. And this is, for us developers, or at least for me personally, was the biggest learning, that it's not all about the code you write. It's actually more about the feeling I give people when I speak to them about these things. And and the last step of this is actually for me. What value do you bring? With this product, we got a lot of new experimentation lines and new things which were impossible before to happen in Booking.com. This brought the company a lot of gains, a lot of new experimentation lines, and also at the same time, moving to this service-centered architecture effort, we have a lot of other devs who were inspired by such projects, and they were willing to create their own services, similar sets in mind. They see it now possible. It's not only about the old that we have, and it's not only about all the technical debt that we have. It's not about Perl and MySQL. You can actually use, when it makes sense, different languages, different services. You can become more tech focused, only about just following the business client. You can use Java, you can use Go, you can use whatever you want. But having people see that this is actually doable, it's massive inspiration which we got out of this project, and also useful for other services. So we have now a lot of other services which provide different types of search, and they're using Sherlock as a backbone or a template for them to deploy their search environments and services. And this is great for the company, because you also use your learnings from previous projects. You don't want every search project to take 6 months or a year. So you want them, also you want the domino effect to happen there. These are all massively influential factors in such a large organization, and it's something which we were happy to deliver. This is basically this sums up the 5 phases of building a product, and how we actually built Sherlock, and how we ended up having it serve these number of requests, without of which any of these steps we wouldn't have been able to reach this phase. This is I just like to share. I like to share with you how we did that, and what vision we're going for now, Booking.com, and how such services are helping us. And I would love to know if you have any questions about this or feedback. Okay, I think that was either very clear or very uninteresting. I'm glad I had the chance to speak in front of you. So thank you very much, and enjoy the rest of your day. Thank you.